Welcome to Kanerika's podcast, The Digital Shift. Imagine waking up tomorrow and finding out that Apple is suddenly manufacturing, like, diesel pickup trucks.
Oh, wow. That would be a pivot.
Right. Or imagine Ford releasing a brand new flagship smartphone. It sounds completely absurd, but that is exactly the kind of massive multi-billion-dollar collision happening in enterprise data architecture right now.
Yeah, it really is. It's a total collision.
Because usually, when we look at the enterprise technology landscape, there are clear, well-defined lanes. You have your database sitting over here, your analytics tool over there.
Exactly. And everyone just plays nicely in their own highly categorized sandbox.
Which keeps procurement teams very, very happy.
Oh, absolutely. I mean, 3 years ago, the lines were incredibly rigid. The division of labor was just crystal clear across the entire industry.
You had specific tools for specific jobs.
Right. Organizations utilize Snowflake almost exclusively for their structured data analytics and business intelligence. And then they turned to Databricks when their data science teams needed to build, machine learning models.
So two completely separate tools for two completely separate jobs.
Exactly. But stepping into the reality of 2026 today, that dividing line has been completely erased. I mean, wiped out.
We are essentially witnessing a massive head-on turf war right now. Both of these platforms crossed the $5 billion revenue mark in 2024.
$5 billion. It's just massive.
And they did not achieve that by staying in their lanes. They did it by directly invading each other's territories. I mean, Snowflake added comprehensive machine learning capabilities, and Databricks went and built robust SQL data warehouses.
Yeah, they are directly going after each other's core customer base.
So you might be asking, why are we dedicating this entire discussion to these two specific platforms? Well, because if you are an enterprise leader listening to this right now, your choice between these two giants is going to dictate your cloud infrastructure costs for years to come.
Decades, potentially.
Right. It will shape the daily productivity of your engineering teams. And frankly, it will determine if you can actually deliver on those executive artificial intelligence initiatives that, that every board of directors is demanding right now.
Yeah, the stakes are just incredibly high. I mean, this is no longer merely a technical choice about software preferences. It is a strategic business trajectory.
Absolutely.
The architecture you commit to today dictates your operational agility tomorrow.
Which brings us to our mission for this discussion. We are going to comprehensively analyze the underlying architectures, the pricing mechanics, the AI capabilities, and the real-world deployment strategies of both platforms to help you navigate this high-stakes decision.
It's a lot to cover, but it's so important.
It really is. And I think the best analogy to frame this conflict is looking back at the smartphone wars from a decade ago.
Oh, I like that comparison.
Yeah, you have two completely different foundational design philosophies, right? But they are suddenly trying to build the exact same all-in-one device for the enterprise consumer.
That framework applies perfectly, actually. Because to understand why these platforms perform so differently under pressure, we absolutely must look at their foundational DNA.
Right, where they actually came from.
Exactly. Let's begin with Databricks. So Databricks originated from the creators of Apache Spark. And from its inception, it championed this concept known as the data lakehouse.
The Lakehouse, which is kind of a mashup of a data warehouse and a data lake, correct?
Precisely. And functionally, the lakehouse is brilliant because it completely decouples your data storage from your computing power.
Okay, so what does that actually mean for the user?
It means it allows organizations to process massive data sets directly in their existing cloud provider's storage. We're talking about structured tables, semi-structured data, and entirely unstructured raw data.
Unstructured meaning, like what exactly?
Things like massive video files, audio recordings, raw system logs. And it does all of this without having to move or convert the formats first.
So Databricks essentially leaves the data exactly where it sits in the raw lake, and it just brings the heavy processing power directly to it.
Exactly. It doesn't force you to move your data.
Now, contrast that with Snowflake's DNA. Snowflake was built from the ground up with a proprietary cloud-native architecture.
Right. A totally different philosophy.
Completely. Its creators really wanted to eliminate the absolute nightmare of maintenance that came with traditional on-premise data warehousing.
Oh, the maintenance was awful back then.
Right. So to fix this, they cleanly separated the architecture into three distinct layers. You have storage, compute, and cloud services. But the crucial distinction here is that everything operates strictly within Snowflake's managed environment.
Yes, you have to play by the rules inside their ecosystem.
Exactly. It was heavily optimized for structured relational data and SQL schemas, offering near-instant query performance for business users.
And that mechanism of how they handle data is the defining divergence here. I mean, Snowflake requires you to ingest your data into their proprietary storage format to get that incredible speed.
Whereas Databricks operates on open formats in your own storage,
Right.
here is where I think an analogy really helps visualize the mechanical difference. So, Snowflake is essentially a high-speed bullet train.
Okay, a bullet train. I like it.
Yeah, it is incredibly fast, highly efficient, and a remarkably smooth ride. But, and this is the bit, but it requires you to lay down the tracks first.
Meaning you have to do the prep work.
Exactly. You have to structure your data into neat, tidy rows and columns. You have to put the data on the tracks to get the speed.
Right, right.
Databricks, on the other hand, is like a heavy-duty, all-terrain vehicle. It does not need pre-laid tracks. It's built to drive straight into the muddy, unpaved swamp of raw data.
Like those random PDF files and video logs we mentioned earlier.
Exactly. It just processes them right where they sit in the wilderness.
That is a perfect analogy, because that architectural distinction dictates literally everything else about the platforms, especially when we talk about performance at scale.
How so?
Well, when Databricks processes enormous, messy data sets, it utilizes distributed computing. Its Apache Spark engine is specifically designed to handle highly complex transformations across multiple clusters simultaneously.
So it's breaking the work into pieces.
Exactly. When we talk about ETL jobs, extracting raw data, transforming its structure and cleaning it, and then loading it for analysis, Databricks can process large-scale ETL up to 12 times faster than traditional systems.
Wow. 12 times.
Yeah, it absolutely thrives in that unpaved wilderness you mentioned.
But on the flip side, Snowflake optimizes for immediate SQL analytics.
Yeah.
I mean, if a business analyst needs an executive dashboard to load instantly right before a board meeting.
Which happens every day.
Right. Snowflake's virtual warehouses resume in fractions of a second. There are no startup delays or cluster warmups. It's just instant speed on the tracks.
And the causality here is vital to grasp. Because Databricks leaves data in the raw lake, you are not paying a premium to a third party for proprietary storage.
But that architectural choice completely changes how your finance team gets billed, which naturally brings us to the economics of scale.
The dreaded billing conversation.
Always. Let's examine the pricing mechanics, because how these systems are built directly dictates how they drain your budget.
Very true.
So Snowflake uses a credit-based system. Because it separates storage and compute so cleanly, finance departments actually get highly predictable forecasting. You pay a flat, negotiated rate for the storage layer, and you spend credits only when the compute layer is actively running.
And they built in this brilliant auto-suspend capability, right?
Yes, exactly. If an analyst runs a query and then goes to lunch, the virtual warehouse detects the idle time and automatically halts the compute. It immediately stops the billing clock.
It is an incredibly elegant mechanism for controlling costs without requiring constant human oversight.
It really is.
Databricks, however, utilizes the DBU, or Databricks Unit, model, and the billing here is fundamentally dual-layered.
Dual-layered meaning you pay twice.
Sort of. You are paying Databricks for the compute management software, but you are also paying your underlying cloud provider, like AWS or Google Cloud, separately for the actual infrastructure, the raw storage, and the networking.
Honestly, paying two separate bills for one data operation sounds like an absolute headache for procurement and finance.
Well, predicting the total cost of ownership is undeniably more complex. There's no getting around that. However, because engineering teams have that granular control over the underlying infrastructure, they can leverage cost-saving mechanisms like cloud spot instances.
What exactly is a spot instance for the listener?
Spot instances are essentially unused, discounted server capacities offered by cloud providers. They are extremely cheap. But the catch is, the cloud provider can interrupt and reclaim them at literally any moment.
So they can just pull the plug on your compute.
Exactly. But because Databricks gives you deep infrastructure control, you can route your non-time-sensitive batch workloads to these spot instances. And doing that frequently reduces compute costs by approximately 40%.
40% is a massive saving for a large enterprise.
It's huge.
But, I have to push back a little on the prevailing industry narrative here. We always praise Snowflake for its predictable credit pricing.
Right.
But does that predictability actually mask a hidden trap? I mean, if you have these serverless automated features that effortlessly and frictionlessly scale up to meet demand, what happens during a period of massive user concurrency?
Oh, I see where you're going with this.
Yeah, see, it's end of quarter reporting, and 500 people log in simultaneously to run really heavy queries. Could a CTO wake up to a massive unexpected credit burn precisely because the system performed exactly as it was designed to?
Well, it is only a trap if you fall asleep at the wheel.
Fair point.
Snowflake does provide incredibly robust, customizable resource monitors and hard limits to prevent runaway queries. You can set alerts in specific credit thresholds.
So the tools are there.
The tools are there, but your underlying point is completely valid. If an administration team ignores those monitors and fails to establish firm guardrails, Snowflake's frictionless scaling will frictionlessly scale your monthly bill right into the stratosphere.
Yeah, it is the inherent cost of ultimate convenience.
Exactly. Now, with Databricks, engineering teams have to manually tune the cluster sizes much more frequently. It requires more hands-on administrative effort, but it violently forces you to be highly aware of the exact compute you are provisioning at all times.
So it's the classic enterprise trade-off, right? Administrative overhead versus financial guardrails.
Always.
And speaking of administrative guardrails, the security architectures and ecosystem integrations of these two platforms are fundamentally opposed. Snowflake takes a very definitive secure by default approach.
They really do. They engineered multi-layered security into the core architecture from day one, removing the burden from the user entirely.
Which is nice for peace of mind.
Absolutely. You get automatic AES 256 encryption for all data, whether it is at rest or in transit over the network. And as of October 2024, they actually began enforcing multi-factor authentication by default for all new accounts.
The administrators don't even have to configure it.
Exactly. The platform just mandates it.
They also heavily promote data clean rooms. Now, for the listener, a data clean room is essentially a secure digital vault. It's where two completely different companies can bring their data together for joint analysis without either party being able to see the other's underlying raw information.
It is massive for industries like advertising and healthcare.
Oh, absolutely game-changing. Now, Databricks, conversely, approaches security through their Unity catalog.
Yes, Unity Catalog is a highly powerful centralized governance tool. It's designed to manage all data and AI assets across the entire organization.
But it's different from Snowflake's approach, right?
Very different. Unlike Snowflake's pre-built walls, Unity Catalog requires active, user-configured governance. The data engineering team must meticulously set up the role-based access controls. They have to specify permissions all the way down to the individual table and column levels.
So it grants incredible flexibility for complex organizations, but you are basically responsible for building the fortress yourself.
That's a great way to put it. You build the fortress.
We also have to look at how these platforms let you share data externally. Snowflake has cultivated a massive internal ecosystem. I mean, they built a marketplace hosting over 1,000 pre-built applications and data sets.
That's huge.
If you and I are both operating within the Snowflake ecosystem, we can securely share live updating data with each other instantly. And we can do that without moving, copying, or transferring a single file.
Which is a flawless experience, provided both parties are paying to sit inside the Snowflake walled garden.
Ah, right. The walled garden.
Yeah. Databricks recognized the limitation of requiring everyone to use the exact same software, so they championed the Delta sharing protocol.
And what makes Delta sharing different?
It functions as an open industry-wide standard. It securely exchanges data across entirely different cloud environments by sending secure, temporary access links to the underlying data files.
Wait, really? So even if the recipient doesn't use Databricks?
Exactly. It works even if the recipient company has never purchased a Databricks license in their life.
Wow. So it is the polished, walled garden up against the flexible open standard.
Precisely.
You know, this focus on massive scalability, raw compute costs, and secure data sharing inevitably leads us directly into the single biggest driver of enterprise architecture today: artificial intelligence.
It always comes back to AI now.
It does. We are currently seeing AI initiatives actively influence 50% of all new enterprise data platform deals.
50%. And AI is the ultimate battleground dictating these architectural shifts. This is specifically where Databricks flexes its historical advantage.
Because of their background in machine learning.
Right. Databricks was engineered for complex data science and machine learning from its inception. They're currently pulling in over $1 billion in annual revenue, specifically from their AI product lines.
$1 billion is not an experimental side hustle. That is a core pillar of the industry.
Absolutely. They dominate this space by offering tools like MLflow, which is an end-to-end machine learning lifecycle management system. It tracks every single experiment and model version.
That sounds incredibly useful for data scientists.
It is. They also recently launched Mosaic AI, allowing enterprises to securely fine-tune massive foundation models using their own proprietary private data. And crucially, Databricks provides deep native GPU support.
Yeah, that GPU support is vital to explain because if an organization is doing deep learning or training highly complex neural networks, standard computer processors CPUs simply cannot handle the load.
They'll just freeze up.
Right. Deep learning requires processing thousands of complex mathematical calculations simultaneously, which is exactly the mechanism GPUs are built for. Databricks handles that hardware acceleration natively.
Meanwhile, Snowflake is playing a highly aggressive game of catch-up.
They really are. They introduced Cortex AI and even launched their own open-source large language model called Arctic. But their mechanism for delivering AI is fundamentally different, isn't it?
It is. They utilize simple SQL functions to call upon pre-trained models. Snowflake is basically attempting to democratize AI by bringing the predictive capabilities directly to the SQL analysts who already understand the business logic.
Right, the people who actually know what the data means.
Exactly. They did add a feature called Snowpark to allow developers to write in Python, but they still lack that native GPU acceleration required for custom deep learning.
So Databricks is providing the heavy machinery for dedicated data scientists, while Snowflake is giving powerful, pre-built tools to the business users.
That's the divide in a nutshell.
I want to bridge this technical theory with reality for a second, because understanding how these architectural differences play out in the wild is critical.
Oh, totally. Theory is one thing, practice is another.
Right. And when our engineering team tackles these infrastructure challenges, we apply these exact technologies to solve massive operational bottlenecks.
I was just thinking about that medtech project.
Yes. Let's look at that recent project we at Kanerika handled for that top global medical technology company. Their executive team was basically flying blind because their data was scattered across disparate legacy systems.
It was a mess. Their on-premise reporting tools were constantly crashing under the weight of the queries.
It was taking them weeks to get critical supply chain insights. So we engineered a solution consolidating all of their scattered structured data directly into Snowflake, and then we paired it seamlessly with Microsoft Power BI for the visualization layer.
Which is really the textbook definition of a high-impact data warehousing and business intelligence modernization.
And the results showcase the architecture's power perfectly. By leveraging Snowflake's optimized compute layer, we at Kanerika achieved a 61% drop in the time it took executives to get critical information.
61%. That changes how a business operates.
It really does. Because the data was finally instantly accessible and reliable, they recorded a 25% increase in actual data-driven decisions across the organization. The bullet train required us to lay the tracks, but once we did, it delivered unmatched speed.
Snowflake truly shines when the data is structured and the goal is rapid reporting. But where does the all-terrain vehicle become mandatory?
Right. What happens when the data refuses to fit onto those tracks?
Exactly.
Well, we faced exactly that scenario with another client, an AI sales intelligence platform. This organization was drowning in massive volumes of unstructured data.
And unstructured data is notoriously difficult to handle.
Oh, it's terrible. Specifically, they were ingesting thousands of complex PDF documents containing messy formats, nested tables, irregular text blocks, all of which they needed to scrape and analyze for market signal.
And let me guess, their legacy relational database couldn't handle it.
It completely choked on the unstructured nature of the files. So we at Kanerika rebuilt their entire document processing workflow on Databricks. We utilized Python for the complex extraction logic.
And by using Databricks, your team completely bypassed the need to force messy PDF data into rigid rows and columns.
Exactly. The compute engine accessed the raw files directly in the storage lake, and the mechanical advantage was immediate. By moving that specific workflow to Databricks, we achieved an 80% faster document processing rate.
That is incredible.
Plus, because the machine learning models had direct, unified access to the raw, unadulterated data, the client saw a 95% improvement in metadata accuracy.
95%. That is a massive leap in quality.
Those numbers perfectly highlight the architectural divide we've been talking about. Highly structured business intelligence reporting demands one approach, while unstructured machine learning pipelines demand another.
Which perfectly highlights the divergence in how these platforms approach intelligence overall.
It actually makes me want to ask a very pointed question about Snowflake's strategy.
Go for it.
Since Databricks was engineered for hardcore machine learning from day one, does Snowflake's SQL-based Cortex AI feel like a patched-on marketing feature? Is it genuinely robust enough for standard enterprise predictive analytics, or is it just checking a box?
It is absolutely not a patch. I'd argue it is a highly strategic democratization of capabilities.
Democratization, okay.
How so?
We have to look at the broader enterprise market. The vast majority of companies do not actually need to build bespoke, custom, deep learning models from scratch.
That's true. Most don't have the talent or the need.
Exactly. They need basic anomaly detection in their sales figures, inventory forecasting, and simple customer classification. Snowflake's Cortex allows a traditional business analyst who only knows SQL to run a complex prediction model with a single line of code.
Oh, wow. So it brings the AI to where the data already lives. Yes. It is exceptionally robust for 90% of standard predictive analytics. But, and this is a big but, the caveat remains. If your core business product relies on custom, intensive AI trained on unstructured data, the SQL approach will fundamentally fall short.
Okay, that makes perfect sense. So, with the architectural capabilities and AI tools established, the final decision ultimately comes down to the human element.
It always does.
Who is the person physically sitting at the keyboard, and what broader cloud ecosystem are they operating within?
Right, the daily developer experience is a massive dividing line here. Snowflake utilizes a SQL-first interface. It is highly intuitive and analyst-friendly.
Very familiar for traditional data folks.
Completely. It relies on web-based worksheets that feel immediately familiar to anyone who has spent their career working in traditional business intelligence or legacy databases.
Whereas Databricks is essentially a scientific laboratory.
Exactly. It utilizes highly collaborative multi-language notebooks. An engineering team can have Python, Scala, R, and SQL all executing sequentially in the exact same workspace.
So it's purpose-built for data scientists who are running iterative experiments, writing complex data transformation code, and testing hypotheses.
When you align the platform capabilities with the actual workloads, the sweet spots just become undeniable. Snowflake rules traditional business intelligence, executive financial reporting, and the massive undertaking of migrating legacy on-premise warehouses like Teradata or Oracle into the cloud.
And Databricks dominates the complex frontiers, processing real-time streaming data from thousands of IoT devices, advanced statistical data science, and complex multi-stage ETL pipelines where raw data requires heavy programmatic transformation before anyone can even use it.
Right. Now, there's one massive external variable that can entirely shift this procurement decision for large enterprises.
Oh, what's that?
The Microsoft Azure factor.
Ah, yes. Cloud politics and vendor alliances play a massive role here.
Historically, Microsoft needed a highly advanced data and AI engine to compete aggressively against Amazon Web Services. But instead of building it entirely from scratch, they formed a deep partnership with Databricks.
Right.
Because of this, Azure Databricks is not just software running on a cloud. It is actually a first-party Microsoft service.
Now, for the listener, a first-party service means Microsoft and Databricks engineered the integration at the deepest infrastructure levels.
And the implications for procurement are massive. You build Databricks directly through your existing Azure invoice. It integrates natively with Microsoft Entra ID for corporate identity management. It links seamlessly to Azure AI Foundry.
All in one ecosystem.
Exactly. But crucially, if you are a CTO sitting on a massive, pre-committed pile of Microsoft Azure Enterprise credits, those credits apply directly to your Databricks consumption.
See, that financial incentive alone often dictates the architectural choice.
Oh, absolutely.
I mean, Snowflake certainly runs efficiently on Azure infrastructure, but it remains a third-party managed platform. You receive the exact same Snowflake experience whether you deploy it on Azure, AWS, or Google Cloud.
Which is a brilliant strategic advantage if your organization's priority is avoiding vendor lock-in. You retain the freedom to migrate your Snowflake environment to a totally different cloud provider down the road.
Right, you're not trapped.
Exactly. But the trade-off is you do not get those deep native procurement integrations, and your Azure credits generally do not apply to the third-party Snowflake bill.
So for heavily Azure-committed teams, Azure Databricks often wins simply on native integration and credit eligibility, even if Snowflake might have been functionally easier for their business analysts to adopt.
It's a huge deciding factor.
Observing these team dynamics and procurement battles, I actually have a theory on where this is heading.
Fair.
I think a significant number of large organizations will willingly choose to pay the premium to run both platforms simultaneously, simply to keep the peace.
Just buy both.
Yeah. You let the data scientists stay in their Databricks laboratory where they have their Python notebooks, GPUs, and unstructured swamps. And while they do that, the business analysts get their instant SQL dashboards and predictable reporting in Snowflake. It completely prevents a massive internal turf war between departments.
It is becoming a very common, albeit expensive, strategy. Operating dual platforms undeniably increases your total cost of ownership and your administrative burden.
But it keeps people happy.
It does. It maximizes the operational productivity of both distinct teams because you are not forcing a machine learning data scientist to hobble their workflows inside a SQL warehouse, and you are not forcing a financial BI analyst to learn Apache Spark just to pull a quarterly revenue report.
Right. So bringing all of these complex threads together, let's recap the critical takeaways from our analysis. Databricks remains the absolute powerhouse for complex data engineering, custom machine learning models requiring GPU acceleration, and highly technical data science teams working primarily with unstructured data.
And Snowflake remains the undisputed champion of operational simplicity, traditional structured analytics, and rapid business intelligence.
It provides immediate, highly optimized value to business users without requiring a massive team of engineers to manage the underlying infrastructure.
Exactly.
And choosing between these platforms really impacts your entire digital trajectory for the next decade. I mean, the right choice accelerates innovation, while the wrong choice creates years of technical debt.
Years of it.
This is exactly where we at Kanerika step in. We specialize in assessing your unique enterprise infrastructure, evaluating your team's technical proficiencies, and mapping your long-term business goals to build highly optimized, high-impact data ecosystems.
Because every company is different.
Exactly. We ensure you are deploying the bullet train or the all-terrain vehicle exactly where your data demands it.
Aligning the architecture to the actual business requirement changes everything.
It is the difference between leading the market and constantly playing catch-up. But I want to leave you, the listener, with a final provocative thought to ponder as we look toward the horizon.
Okay, what is it?
Well, we spent this time discussing how these platforms are colliding by adding each other's features. But as generative AI rapidly evolves, it is increasingly allowing non-technical business users to query massive unstructured data sets using nothing but plain natural language.
Oh, that's true. Just typing questions in plain English.
Right. No SQL syntax required, no Python scripts needed. As that AI translation layer gets smarter and abstracts away all the coding, will the highly technical dividing lines between a data warehouse and a data lakehouse completely vanish?
Wow.
I mean, in 5 years, will enterprises find themselves choosing between these multi-billion-dollar platforms based on absolutely nothing but the raw, commoditized price of compute?
That implication challenges the entire foundation of the current market.
It is certainly something to mull over as you plan your next infrastructure upgrade. Thank you for joining us for this analysis. Keep questioning your architecture, and we will catch you next time on The Digital Shift.